They are a pioneer in voice agents. We have Rahul and Sudhama with us. Travon AI was founded by Rahul and Sudhama with a vision to transform business communications with voice AI agents. Rahul is the CEO and oversees the growth and strategy, and Sudhama is the CTO and handles the technology and products for the company. Rahul has 16 years of experience in leading growth and technology teams across companies like Uber and Google. He is a three times founder with a deep passion for technology like AI and machine learning. He's a graduate from IIT Varanasi and an MBA from ISB. Sudama, on the other hand, is a tech nerd, I can assure you of that, and an NYU computer science graduate with 17 years of overall experience, including in companies like Goldman Sachs. He is also a serial entrepreneur, having founded four startups in the past and bringing in a wealth of experience in product and technology strategy. The way we've planned today's session is, we're going to keep it tight. So, about 10 minutes, the first part where Rahul and Sudama will talk about fundamentals of voice agents. The next 10 minutes will be about the applications which Travon AI makes available to different industries. The 10 minutes after that is going to be a demo which they will give of their products. And the next 20 minutes in the end, we've kept for a very generous Q&A. So with this, I will hand over to Rahul. Over to you.
All right. Hi, everyone. Good evening. I hope you can hear me. First of all, thank you, Gayatri, for inviting us for this session and the whole AAIA team for the awesome job they are doing at pushing AI through India. And also thank you, Renu, for taking out time from your startup for this. As Renu mentioned, I'll quickly go ahead and set up the initial context before I hand it over to Sudama for the technical pieces. Um, so, for years, businesses have relied on IVRs and pre-recorded messages as means of voice communications. Uh, we all know that these systems are rigid, they're cold, frustrating. Press one for this, press two for that, and we kind of get stuck in that loop. And these systems were actually never designed for real-time conversations. They were just designed for general routing purpose, and customers felt that disconnect all the time. And then, the next wave of business communication came in the form of chatbots. And we find chatbots almost everywhere. We see them on websites, on apps of the businesses. And while they introduced a lot of automation, they were often reactive, confusing, and kind of hit or miss without proper training. And one of the major flaws that generally chatbots have is that they don't work for outbound, which means that you cannot really push a conversation naturally over a chat. For example, if you want to initiate a conversation with your customers, you cannot uh, push that as an outbound from chatbots, right? Only if the customer is interested, they will reach out to you through a chatbot and then the interaction happens. So that's one of the major flaws of chatbots. And let's be honest, nobody enjoys typing long paragraphs when they could simply say it. Um, Now, beyond this, there are a few other channels of business communications as well, which are quite prominent. These include emails, SMS, WhatsApp, and of course, businesses use these extensively nowadays. But even these channels have a few limitations, right? So, for example, if you think about it, most of these channels don't support a two-way live interaction, which means that let's say if you want to interact with your customer, uh, you when you send an email, you just pray that the customer might go through the email and might respond, right? And that really happens. So many a times these messages go unread, they are ignored, or even at times misinterpreted. So you can't really do things like negotiating a payment, or you cannot reschedule an appointment efficiently over these static messages. And that's where voice systems comes into play. We all know that voice is one of the oldest, most natural, and a preferred mode of communication, especially in a country like India, where almost like 75% of our population are more comfortable in talking rather than typing. So whether it's let's a business executive, a field worker, or let's say a homemaker, speaking is effortless and it's very intuitive also. So unlike chat and email, voice allows for other aspects. Like for example, you can add emotion to voice, you can add clarity, you can add a tonality to voice. There's also a speed that you can regulate while you use the voice. So all of that happens during one interaction itself. And voice AI isn't just an idea anymore. Recent innovations have made it viable. They have made it scalable as well as intelligent. I'm sorry, I think my camera was disabled by the host, but I hope you can hear me. Let me know if you can't.
Yeah, we can hear you, Rahul. We'll just figure out your camera if there's an issue with that.
Yeah, sure. All right, so I'll continue. So as I said, voice AI isn't just an idea anymore. There are innovations that are making it viable, scalable all the time. And there are several components in the voice AI that has changed recently. What we call this as a tech leap that has happened in the recent few years. So there are various components within a voice AI, and of course, Sudhama, the CTO, will take us through some of these components. But just to give you a high-level picture of how things have evolved in the past few years, um, the speech-to-text component, which is the component where whatever you speak gets converted to a text. We usually call that as a speech-to-text or STT in short. So that has become more accurate. It has started working even in noisy and multilingual environments. Um, there's also language and emotion detection that has now become more prominent, and it has become more real time as well. We all know that large language models like GPT-4, which has transformed the industry in the past few years, has enabled these agents to understand fuzzy queries, handle objections from our customers, or drive certain outcomes. The goals that these voice agents were tasked to do. And also the voice that these voice agents have come up with, which we generally call technically as TTS, which stands for text to speech. So now the agents are sounding more empathetic, calm, energetic, right? There's also been significant progress in terms of the speed of communication and the latency of these communication, right? So more specifically, systems like GPUs and low latency streaming systems have emerged, which has really accelerated the response time and allowed more natural conversations to happen. Another big, significant change that has happened in the recent past is programmatic telephony has emerged, which allows us to make hundreds or even thousands of calls in parallel. So traditionally, through a human, only one call could be made at a time. Uh, but now with these systems, almost 1,000 calls can be initiated in parallel to all your customers. So these systems have become much more scalable and concurrent. And last but not the least, autonomous voice agents have come up, which not only just talk to the customers, but they also understand, they act upon certain logics that are fed to it, and they also decide. So they have this autonomous decision power that allows them to become more powerful. So all of these have cumulatively significantly transformed the industry, and voice AI has now hit that sweet spot where uh, natural UX has met the business ROI as well. So you get the scalability like a bot, but you also experience like a human rep. You can talk to a voice bot on the phone. in any language 24 cross 7. And all of this has inspired us to build Travon AI. So that's a quick context about why Travon AI, why voice bots and how the voice bots are transforming the technical industry as we know. Now I'll hand it over to Sudhama to help us understand the tech building blocks of our typical voice AI systems. Sudhama, over to you.
Hello, can you hear me? Okay. Hi everyone, I'm Sudhama. Thanks Rahul, and yeah, excited to kind of share this with you. And as Rahul was saying, the tech stack, because of obviously the whole evolution of large language models, has been the biggest driver of sort of the momentum that has come towards voice AI agents. And so there's typically two common stacks being used today, and what you see in front of you is actually the most common stack. So imagine that there's a person who either goes to like a website, it could be like a banking website, or it could be for some sort of a vet clinic appointment booking. And you either see like a voice bot interface where you can directly speak to a voice agent through the web, or you can speak through a number which is on the website, right? So you'll just say like, take the number and pick up your phone and call. Now, essentially what happens is the moment you connect, there's a layer in between, like I said, either through the web or through your telephony system. And that connects to this orchestration layer. And this is the crux of the whole system, right? You have individual components like the speech to text, the LLMs, and the text to speech, but the orchestration is where everything gets exciting and spicy. So the moment you start speaking, it could be either you initiating the call, or sometimes you might get called by an AI agent directly, a voice agent also. But the moment you start speaking, that speech is first converted to text. And part of the reason is because you eventually want, I mean, LLMs have been designed until now primarily, like text processing was one of the biggest powers of LLMs. Now, of course, you have like image and audio and video and those kind of things coming in also. But speech, I mean, text was the primary, sort of input mechanism for LLMs. So, the first step is to convert the speech to the text. Once that happens, internally this orchestration layer will take the sentence spoken by the human and then give it to an LLM, along with some context. It's not just the sentence in and sentence out. You will give some context to the LLM even before this whole call starts, right? And the LLM will know, for example, like you'll set up some context to say, hey, this is like an appointment booking agent, or this is like a recruitment agent or a collection agent, and so on. That context, of course, is sort of known in advance, but you can pass it in real time along with this message that comes in, right? And with that context and with the message of the human, the LLM will process it and give back a reply. With that reply, you will pass it on to a text-to-speech model, something like 11 Labs, right, which is very good at sort of generating, close to human-like voices. So you're just passing in the response, and with that response, it goes back to the telephony system, and then the human can hear it. And it could be the telephony system or the web again. Now, this is, a bit of a simplification or an oversimplification, but these are the key core components that one plays with. There are obviously sort of parts of the telephony and parts of how you connect with your web system and so on that are the intricacies of the technology, but this is the most common stack. And the reason it's common is because of this LLM layer, right? Now, the thing that you can do with this layer is, the ability to handle context. The other thing you can also do is, sort of do things like make function calls, or, as they call like tool calling in the AI world, where you might sort of use somebody, if somebody says, I want to book an appointment, and they say, I want to book it for 4 p.m. At that point, once you interpret that, you can also, sort of pass on that information to a part of your orchestration layer, which will then check your calendar availability and then maybe even go on and book the appointment. So it's all of this, sort of connectivity that happens internally, but this is just like a high level stack, which is very common and easier to understand. The next one is speech to speech, and there are like sometimes when you talk to like an OpenAI, the chat on OpenAI, the app itself, they have built sort of models for speech to speech. So essentially, your large language model, which is the LLM, is able to interpret speech directly and then use that speech to again respond with audio. Now, this is great. It obviously eliminates, some of the steps of the speech to text and then text, sort of passing on that to the LLM. But the challenge is, this is very deeply sort of integrated within the LLMs today itself, which makes it less usable for startups like us to directly use them for very specific custom use cases that our customers have, right? So in the appointment booking schedule, or even just, let's say you have like an HR use case and you want to give it a job profile and those kind of things, you can't do that on the fly. You kind of have to fine tune the model. Sorry. So that's why it becomes difficult to use these for sort of skill like sort of custom use cases today, but they are getting there. Hopefully in a few months we'll see some progress on using voice to voice directly, speech to speech, and the advantage of that is obviously by reducing the number of steps, we can reduce the latency on the calls, right? Now, speaking of that, basically when we talk to a lot of the customers, both in India and abroad, globally, there's like four key elements and customer needs that companies talk about today, right? So there is, those are mentioned in the middle. There's low latency, there's the voice quality, there's obviously the cost and the conversational flow. So let's talk about latency first. Essentially, when we have a human conversation, human to human, we don't perceive any delay below 500 milliseconds typically, right? And it sounds like 500 milliseconds. I mean, it's like pretty much like a fraction of a second. Obviously, humans are pretty fast at processing, right? But today, everyone's like aiming for as an ideal latency for a voice agent is around 900 milliseconds. It's very hard to achieve this. So I wouldn't put that as the expected value. Obviously, at this value, it's like immensely natural as a conversation, and that's what we are, constantly aiming for as well. But the acceptable range is somewhere in the 1.2 to 2 second range, closer to 1.2 seconds. If you get that, and then 2 seconds, you don't feel it as much. If you still hear like, the moment and this 2 seconds or the 1.2 seconds, what we're talking about is the moment the agent stops speaking or the moment the human stops speaking and the agent starts speaking. That's the gap that we're talking about here, where we don't perceive. That's like the latency gap or the end-to-end latency that most companies talk about. The next is obviously voice quality. Companies care about this a lot, and it's a lot of work to get a good quality voice going. And that's because as humans, we have like different, like you want it to sound as human as possible. And humans very naturally have, different like tonality, emotions, prosody, intonations, and so on. We emote different emotions, right? And that comes out in our voice first. So, trying to get to that is where the industry is trying to get to day by day. But it's a challenge for sure. But we are seeing really good voice qualities, even that we are working with. And we oftentimes see like, even we are surprised when people talk to a voice agent and call it like, yes, sir, yes, ma'am, or, they just respond like a human. And so we realize that they don't really perceive the difference. So it's already there today. You also don't want it to be too fast, not too slow. You don't want to be too chirpy, too loud, or too calm in that sense, right? Too monotonous in the voice. So that's as far as the quality. And these are things companies care about and they tell us today as well, right? And then the cost. Of course, India is a very price sensitive market, so it's again a lot of work trying to get to build a low cost voice solution, and we put in a lot of engineering around that as well. But obviously, low costs then come with trade-offs. The trade-offs are primarily in terms of the voice quality and latency. So you may use like a voice model which is trained on some older technologies, and you might, if your use case is very simple, then some companies are okay with that. For some other use cases, you want the quality to be better, right? And finally, the conversation flow, right? The moment your conversation becomes a bit more complex, for example, at the least, let's say you have a lot of questions. Let's take the recruitment example. You have a lot of questions. You want the interview to go as per the script and ask questions in a certain flow. You also don't want hallucinations or to say anything wrong about the company, or let's say, the salary expectations and so on. You also want to support like maybe tool calling, for example, for booking an appointment in a vet clinic, or for instance, let's say you want to hand over to a human. All these become part of your conversational flow handling, and then all of this takes engineering basically. So, one of my favorite analogies of thinking about building voice agents, and I'm talking about the orchestration a lot, is thinking of like designing an F1 car, right? Every 100 milliseconds counts because you're fighting for that. Low latency is really important. You want to make sure that it feels natural. The only difference compared to making a Formula One car is that there's no limit to how much you want to make a Formula One car faster. But you can't make a voice agent so fast that it sounds like a chaotic family dinner. So that's something to think about. You can't go, maybe below 300 milliseconds, even if the technology allows it. So just to give you some context, and this is, purely like some of the defaults where you might use an STD service like, a DeepGram, or some of the typical large language models, like an OpenAI or a Claude, for instance. So I'm talking about like you're just trying to give you some sense of, how the latency adds up. So we're talking about 200 to 400 milliseconds in terms of the speech to text, and then 400 milliseconds to 2.5 seconds for the LLM pieces. This is from the most sort of common stacks. You can go a bit lower on the LLM sometimes. And then for the TTS, which is the text to speech part, you are typically in the range of a 600 milliseconds to 1.5, sometimes even more. And then you have to also take into account network latencies, right? Which means your telephony system that your audio is passing over on the side of the human to speech to text, and then whatever audio gets produced goes back to the human. There are some latencies there as well. And even if you're talking to a web-based voice agent, again, if it's crossing the wire, there will be some latencies as well. So this is just the default breakup, and then you engineer stuff to make it faster. The one thing I want to say is that there are optimizations. For example, sometimes on the speech to text, you might use a streaming service. What that means is it doesn't send you the full sentence audio at once. It'll just send you chunks of sentences transcribed, right? And that those kind of things help make it faster as well. Now, one of the sort of the most key global challenges that even today companies are trying to get better at is end of turn detection and interruption handling, right? These are things that humans cannot do very naturally, but when you have to engineer this in a voice agent, it's a lot of work, and people are still trying to make it better. So what you're seeing in front of you is an example where, let's say, you're talking to a recruitment agent which is interviewing someone for a sales job, and now the agent asks like, oh, can you share an example, some examples where you exceeded your revenue goals, right? And the agent finished speaking. The human obviously knows when to wait. So the human says, yeah, sure. Like last year I worked on 2 deals. And just when it's just about finished saying that, if the agent incorrectly detects that the human has finished speaking, the agent might just say like, oh, great, unless it, fully interprets the context just purely based on, hey, the text transcription was done. it might start speaking, right? And so the agent said something, and the human very naturally might have just continued to say, like, yeah, the first one was like a 235 million, and then realized that the agent was in the middle of saying something also. So the human kind of continued naturally as though it was, he was going to say or she was going to say the next sentence, but was, sort of interrupted by the agent. And then the human starts speaking. And when the human starts speaking, it is possible that the agent might not detect this correctly, that the human is speaking, and then go on to ask the next question, like say something like, hey, just moving on to the next question. And this essentially is incorrect interruption handling. So these are the two key challenges: knowing when the human is actually finished saying what they're trying to say, versus just finishing a sentence. And the other is, not interrupting at the wrong time. So, so these are essentially two challenges that are there to be solved. There's more. It's obviously not just that. One of the other challenges, obviously, yeah, you did the transcription, and there are some like multiple companies doing transcriptions. I've taken this graph from a company called DeepGram, which is really good in terms of speech to text transcription. So, we haven't made this a chart ourselves. One of the key things that you want to do is obviously have accuracy. So a lot of companies today, and pretty much everybody wants 100% accuracy. It's not there yet, but it's getting pretty close. And so there is this concept of WER, which is the word error rate, and that tells you how inefficient your transcription, or how, your inefficient your transcription rates are, and or how many, like what percentage of words are incorrectly transcribed. DeepGram, with its latest model, Nova 3, claims to be, close to like 7%. And it goes as worse as 22%. And this is data from some time back. So, I'm sure that maybe models are improving there. But this is just, what we see, we've talked to companies, is that the human error rate can also be anywhere, 5% or more, right? Depending on, the kind of people that are handling it. So just so you know that it's not that humans don't make mistakes. So, the transcription services are already pretty close, but, it is still getting better day by day. Now, where do the challenges come from? They come in from the fact that, there's multiple languages, right? So most of the models today are designed to handle one language at a time, because it takes a huge amount of training data to train them. It's not easily available. There's 20 popular global languages, but there's over 7,000, global languages. 44% of them are not like about to become extinct, but there's still a lot of languages. In India, there's like 120. Obviously, there's dialects. There's different accents, right? So even in the same state, you'll see different people talking in different accents, depending on the state, of course. The other big challenge is background noise. So, this is where voice detection comes into place. It's called like VAD, voice auto detection. So, if there's a train in the background, it's handled differently than if it's someone listening to music. And we've experienced this ourselves on sort of these agent calls. And there also could be people talking behind you, because you don't know maybe when an agent might call you. So that's one problem. And then there can be telephony or network problems, right? So if that's not great, then the audio that goes to the speech to text service may not be great as well, and that can become a challenge. Anyways, that was just an overview. Rahul, over to you, just to talk about some of the industries we're talking to and working with.
Yeah, sure. Thanks, Sudhama. So quickly moving on to the kind of applications and industries that we serve. See, so we serve a lot of host of industries actually. Um, for example, one of our typical use cases is a front office receptionist, where instead of a human receptionist, you can have a voice AI agent serving as a front office staff, um, typically working for hospitals or dental clinics or veterinary clinics, where we have seen that with a human staff, most of the times, almost more than 40%, uh, results in missed calls, right? Your customers are calling, but there's no one available, maybe due to odd hours or end of the business hours. So there's no one to attend those calls, and that leads to a lot of missed calls. There are also lost upsell opportunities because of improper training of the human agents. So that's where one of the interesting use cases comes in the form of front office staffing. The other interesting use cases is also around collection agencies, right? So a lot of banking and non-banking companies, NBFCs and BFSI companies, they use human collection agents who would typically call customers or email them or send them SMS in case there are amounts due for a significant longer time. And all of those systems we have found that can be replaced by voice AI agents as well as extensions of voice AI agents. So we have found that that results in a significant improvement in ROI, which is typically 10 times better than the human collection agents. And that also leads to a significant reduction in cost. The other interesting use case for voice AI agents for collection industries is also in training the AI agents. And I think Sudhama will show you an example of demo of how that works. But there's a role play that happens where you as an AI, you as a customer can talk to an AI agent, or let's say you as a collection agent can talk to a customer, which could be a simulated customer in the form of a AI agent. And then you can simulate these scenarios where the customer could be a hard customer or maybe a difficult to crack customer. And those kind of simulations can be done for training the human agents. Um, as Sudhama mentioned, we also find a lot of application of voice AI agents in the recruitment industry, especially for screening candidates or video interviewing the candidates, where we have found that through these voice agents, almost more than 80 hours of efforts per recruiter gets saved every month. And that's a significant saving, not only in terms of effort, but also in terms of the cost, because that leads to almost like 70% reduction in the uh, cost of hiring as compared to a traditional hiring. Customer support is again a very easy to understand, intuitive use case where instead of humans customer support, you can have uh, an AI voice customer support, which typically we have seen works for vehicle service industry. So, for example, let's say if your insurance is expiring, you would expect the vehicle service owners to call you up and uh, inform you prior to the expiry that hey, your insurance is about to expire. So those kind of scenarios are also handled through these voice agents. And last but not the least, in the D2C industry, we find that these voice agents are quite actively used. It's getting adopted significantly faster. And one of the good use cases over there is in the reactivation of churned or inactive customers, right? So, for example, let's say uh, if you're owning a D2C industry and you have a lot of your customers who might have churned or might have been inactive for a significant amount of time. So you really want to talk to them, try to understand what their problem is. If there's anything that can be solved, you want to solve that. So through a traditional mode of communication like emails or text, you cannot have those bidirectional conversations going. But through these voice agents, you can call up your customers, maybe thousands of customers every minute, and you can have a very personalized conversation with them. You can try to understand what challenges they are facing, and then you can try to solve for those challenges. So I think these are some of the very interesting use cases, and again hand it back to Sudhama, who can take us through some of these demo sessions and can show us how this works actually in the real life world. Sudhama, over to you.
Yeah, thanks, all. Yeah, so excited to show you, just some sort of samples, and a demo of the product as well, or the products we're building. Just I'll be playing a few recordings, and we'll play one recording and then go to the the dashboard for the product, how we're doing this. This is a mix of sort of US, customer use cases and Indian. So you'll hear a mix of voices, and then we can talk about that in just a second.
Hello, this is Salma from Amity Veterinary Clinic, and we are here to take care of your pet. How can I help you today?
Yeah, I need an appointment.
Of course, I'd be happy to help you book an appointment. Could you please tell me your pet's name?
Yeah, it's Shani.
What a sweet name, Shani. Could you please share the concern or reason for the visit for Shani?
Yeah, she's been vomiting.
I'm so sorry to hear that Shani has been vomiting. That must be concerning for you. Let's get her the care she needs. Would you like to book an appointment for today or another day?
Today would be great.
Let me check the available slots for today. One moment, please. It seems that the earliest available slots for today would need to be a bit later. Let me check for availability starting from the afternoon. One moment, please. It seems that the earliest available slots for today are already passed. Would you like me to check for availability tomorrow instead?
Sure.
Checking available slots for tomorrow. For tomorrow, we have the following slots available: 9:30 a.m., 10:30 a.m., 11:30 a.m. Do any of these times work for you?
10:30 is fine.
Great. I'll book the appointment for Shani at 10:30 a.m. tomorrow. Could you please provide your name?
Yeah, it's Martin.
Thank you, Martin. Could you also share your phone number so I can complete the booking?
It's 5134218879.
Thank you, Martin. Lastly, could you please provide your email address? If you'd like, I can use our placeholder email, which is sudhama@qrev.ai. Let me know what works for you.
It's martin.5@gmail.com.
Thank you. Just to confirm, your email is martin.5@gmail.com. Is that correct?
Yes, that's correct.
Booking the appointment for Shani at 10:30 a.m. tomorrow. Your appointment for Shani has been successfully booked for tomorrow, February 6th at 10:30 a.m. Please arrive 10 minutes early. We also have a 24-hour cancellation policy. Is there anything else I can help you with?
No, that should be fine.
So I'll pause it here just in the interest of time, and so that we can leave some time for questions as well. I'm just going to quickly give you an overview of, the dashboard. So we build this special, product, for vet clinics called, it's the product, we call it as Concierge. That's for vet, vet owners, pet owners, pet parents as they're called. So essentially what you're seeing is like a dashboard of, all the calls, so our customer will have access to all the calls that are made.
Dashboard, Sudhama, we are not able to see a dashboard here.
Sorry, just one second.
We are still in the old screen.
My bad. I think I'd shared the other screen before. Okay. Okay. You see it now?
Yes.
Okay. Okay. Sorry. So I was saying that, we built this sort of product for vet clinics called Concierge. Essentially our customers would be able to see, what calls are being made, inbound or outbound. So it could be for appointment booking or outbound for like reminders and so on. So they have full access to understanding. It's almost like having a team of humans, right? You can see who's the best performing agent. You can see the average times, per call, for instance. And, that's just the dashboard. The way you sort of come up or set up these agents is you can choose. So you have we've chosen to create different agents for different specialties. So, an appointment setter would help you, sort of follow a specific flow, and then reminders would follow a specific flow. We find that works better rather than, sort of plugging in all the context for every single thing, because we also have to add things like the knowledge base and certain FAQs and so on. So it's better to kind of tailor it for the use case, right? So as an example, if you have someone just doing an outbound call for like sending a reminder for an appointment, so you heard the appointment booking audio recording. Now let's say you want to create an agent which is similar. You could use a template like that and then maybe predefine certain things like a simple greeting message, which would be preferable for your sort of a brand. You can put in an example script of how your conversations typically go. You can also give us like a knowledge base of information about, it could be information about sort of questions that more customers mostly ask about their pet, right? They're vomiting, or they're not feeling, maybe they must have bitten something, or they're running around howling, so on and so forth. So you can give us that kind of context. You can also put in some FAQs if you want, those kind of things. You can define the kind of conversation style. So it could be enthusiastic and chatty, or professional and to the point. So you can configure these agents to your liking. You can put in simple titles, but you can also, the more important thing is you can select voices for different, customers or different countries. We've also created this sort of rule-based system, because in some cases, let's say you're targeting maybe senior audiences. So you might say, okay, based on the, the age of the recipient, you want to create some rules where you might have a more mature voice, and maybe based on the recipient location as well. So those kind of things are possible. And eventually, you could upload a contact list, which is just a CSV file, and then prepare that, and then, preview and deploy your agent. Once you do that, essentially, once the calls start to go out, you have access to the calls being made by the agent, and you can actually see exactly what different calls were made. You have access to the transcripts of these different calls, and the call recordings as well. So we give that to our customers. And finally, if they're booking appointments for you, then you can also see their appointment bookings, what time, the link to the appointments, and so on. So yeah, those things are all accessible. And finally, we've created like a fun dashboard for you to track and see which ones are doing better. I know I've shown this on the main dashboard, but this is just like your leaderboard of different agents. So over time, you can see where you want to maybe leverage different agents for. So that's that. I will quickly do a demo of a collection agent training. So as Rahul mentioned, the idea here is, we have agents which can do the job of a collection agent, but you can also use it to, role play with potential customers. So your agent is basically testing themselves against potential customers, and that's like.
So who is this?
Hey, is this Sarah?
Yeah, this is Sarah. Who's this?
Yeah, this is Sudhama calling from the vet collection agency.
Oh, hi. How can I help you?
I mean, you have an outstanding of $537.50 per month, so that's about $80,000 due.
Oh, yeah, I know. I've been meaning to sort that out. It's just things have been really tough lately. I lost my job recently, and everything's kind of a mess right now.
Yeah, I'm so sorry to hear this, Sarah, but unfortunately, this is escalated to a point now where, we have to get in, and, we want to avoid you having impact on your social security as well.
So, I'll just pause it here again in the interest of time. But the idea here was, we are, you have humans that can train in the meantime. Obviously, collections is a very sensitive space as well, right? So as companies take on these agents, there is also an opportunity to, take some of the more difficult cases, or just make some of the existing collection agents, better till AI fully sort of does most of it. So for example, you can test yourself against like an easy, like a customer that was the example I just played, which was Sarah. She's lost her job, willing to set up a payment plan, but she's anxious and she's still cooperative and honest as well. And similarly, you could have other types of customers, and the difficulty level increases as you go, right? So you can do that. You can also role play against, your customers in that sense. So, you can play the agent, you can also play a customer, for example, to be more empathetic. So then that, hey, when I'm talking to a real person, I need to display it because now I can play that role and I understand what someone might be going through, right? So these are just examples. Renu, do we have time to just play the audio for the last use case?
Okay, maybe like 1 more minute, just quick
Yeah,
one.
30 seconds. Yeah, okay,
Okay.
cool. Just to play the Indian voice in this case, right? Just so people can hear that.
Hello. Hello. Hi, I'm Murali from Palm Money. Am I speaking with Ankit? Yeah, speaking. I'm calling regarding a great opportunity for an investment analyst role with Palm Money. Your profile was reviewed by the hiring manager and they're keen to explore further. Do you have a quick 5 minutes to chat now? Yeah, sure, we can talk. Palm is a Series A funded fintech startup backed by Plexus Venture Partners and Seed Capital. The role is based in Bangalore, full-time in office, with a CTC of around...
Okay, there you go. So yeah, that's it on my end. And
Thank you. Thank you, Rahul and Sudhama. I think this was very exciting for me. I'm sure for everyone else also. From the three, I think the last one is the one, like from the three demos, I felt the first one, I could tell like there is, an agent, like non-human person involved. And I think it evolved from the second one where I was a little lost. But in the third one, I think one could say, it looked like there were two human beings talking. So I think maybe that is how the technology is evolving as well. I have a couple of questions, but I think before I ask, I'm going to ask from the audience if anybody has a question for Rahul or Sudhama. You can even write it in the chat box if you'd like to.
Hey, this is Anand. I had actually put a question in the chat earlier. Rahul, Sudhama, thanks. It's a good demo. Actually, like I come from recruitment industry and we have just completed our own voice AI bot. So it's very interesting to see what you've done. Very comprehensive, of course. We are not going to create as comprehensive as you have done. That is not our charter. But I was just curious to hear from you, like, Rahul, you were mentioning about multiple parallel calls, because that's one area, honestly, we are very, very much struggling. If you can shed some light without sharing maybe your IP, then I'm more than happy to listen. Thanks.
Yeah, sure. Thanks a lot, Anand, first of all, for your question, and great to hear that you guys are also working on a similar space in the recruitment sector. So, as I said, concurrent calls is something that has added yet another dimension to this whole voice industry, right? Because earlier, through a human, you could just make one call at a time, but now with these voice agents, you can make concurrent calls, right? And some of these functionalities are enabled primarily um, through the telephony systems, which allow us to programmatically make these calls, right? So there are telephony systems, for example, Twilio or Plivo or Exotels of the world, which have these concurrent channels, which allows you to send out multiple calls at once. So, for example, Twilio, which is one of the popular telephonic channels in the US, claims that you can make even 1 lakh calls per minute through it. So, those are some of the systems that enable these kind of concurrent calls. But of course, it's not just the telephony system which is sufficient. The entire tech stack has to be compatible to make these voice calls, and that's why you need to have this functionality where you can pass on these dynamic parameters to your voice agents so that more customized and personalized communications can be made. Right now, what are these dynamic parameters? These dynamic parameters could be simple things like, for example, the phone numbers of the people you want to call, or the name of the people you want to call. But it could also be a complex set of things like, for example, uh, what were the past interactions with that customer, or let's say with the candidate, right? Uh, how has the candidate history been, right? So those kind of dynamic parameters can also be passed in real time, so that when these calls go out, these are not just, they don't sound robotic, they don't sound automated. These are very personalized and contextualized to the to each candidate who is receiving the calls, right? So yeah, that's how it works. Of course, we can connect offline to discuss more on that.
Sure.
Yes, Mr. Sriram, please go
Yeah,
ahead.
Rahul, I have a question here. Am I audible?
Yes, you are.
Yeah. How flexible are we in terms of the languages? Because I come from a background here, staying in India, and Indian market. Though I don't know about the pricing, but the language. I just wanted to understand whether it is a language flexibility, or in terms of penetrating into the market, then language plays a major role, right? Even across the US, if you say the language, the accent is entirely different when it comes to the east and the west. When you go to Utah, it is entirely different. So I just want a concern here in India, down south, is it a language flexibility where somebody buys a product?
That's a very good question, first of all, Sriram sir. Because as you rightly pointed out, even in English speaking countries, for example, the US, there are differences, right?
Yeah, yeah.
The East Coast speaks in a different accent
Sure,
than the
sure.
West. So good thing is that most of these voice agents, and especially the speech text part, uh, have been trained to understand these monolingual kind of situations, right? So, for example, they are well trained to understand the language and accent variations for one language, which in this case could be English,
Hmm.
but it could be any other language, for example, Hindi also, right? Uh, but when it comes to mixture of language, right, which we call as a multi-language scenario,
Hmm.
that's where things start getting a bit more complicated,
Complex.
uh, because of course people not just mix languages, they mix different nuances also, right? There are
Hmm.
different ways of saying the same thing in different languages,
Yeah, yeah.
and it's very hard for us or even for an AI bot to understand that seamlessly and speak in the same way back to the customer,
Sure.
right? So that is definitely one of the areas which is, I would say, which is kind of in an evolutionary phase. Uh, People have been able to develop these systems. In fact, we ourselves are working on these kind of systems where the AI agent can speak and understand these multilingual scenarios. But I think we'll still have a long way to go, especially for the Indian context where, accent, dialects, and, these multi-coded languages, they add to the complexity.
Thank you, Rahul.
And so on.
As a question in the chat box from Jayashree, which LLMs have been used in developing? What is the contextual memory in voice AI?
Yes, so I can maybe answer that. Thanks for the question, Jayashree. So again, the more there's a few that are out there, right? Which is OpenAI, there's Claude, right, and there's obviously Gemini by Google, and then there's a few other solutions also, right? Now, as I mentioned before, a lot of it comes down to your use case, because even within OpenAI, for example, there are multiple models. There's like the 4.1 nano, which has just come out recently, which allows you to have maybe a little less latency, and also some better cost, right? For instance, but you may, depending on the use case, want to use something maybe which is more reasoning oriented and use a 4.0 like kind of a model, right? So we work with various different models to tell you, like, in short, it's not just to kind of give a vague answer, but it is really for every customer. You have to use like a different combination that suits their need, basically. And it comes down to these parameters, right? Like your latency, your cost, the quality, and then that holds same for the STD part, the LLM part, and the TDS part as well.
There's Sorry, is someone asking a question?
Sorry.
Okay, I think that was my voice echoing. Sorry.
I didn't know answer on the contextual memory. I can answer that if you want.
Yes, please go ahead.
So I think, if I understood this correctly, Jayashree, you mean that, maybe you want to, like I mentioned before, keep giving the LLM enough context so that as the conversation holds, it is able to conduct the full uh, conversation correctly, and even also keeping in mind what it has already asked and not maybe repeating questions or those kind of things, right? So one of the things that happens is that, and this is one thing to note in terms of your cost evaluation also, that as the conversation becomes longer, you are giving it more and more context because you're giving it your initial context, but you're also giving it maybe your conversation history. So that becomes larger as you go, right? And how you manage that again becomes an engineering problem where, if you want to control your latency and costs and all those things, you have to, find better ways to handle the context as it grows. But you can continue to extend it as far as the memory goes.
Gayatri, we've reached the 1 hour mark. if I see a lot of questions and I have questions myself. So do we stick around for another
Yeah,
15
I
minutes?
think another 10 minutes because these questions are important and I would like to,
Yeah.
Okay. Okay. Maybe
Yeah.
I'll just like throw my two questions, in between. Like I just intersperse them with questions.
Take this question, Renu, if you will allow me to the one that Ram has put up here. That
Yes,
seems to be
yes.
intriguing.
I'll
Yeah.
just I don't know if you guys have read that question. So, I think Ram is asking, how does your AI agent handle interactions with abusive or aggressive callers? Are there specific protocols in place to de-escalate or end such conversations while maintaining professionalism? I think I want to just chip in and say that the best part is that the abuse is being hurled at like an agent and not a human. So it doesn't really matter. I mean, it'll transcribe it and say, bad caller. But yeah, over to you guys.
Yeah. I want to, to exactly what you said, Renu, like that's, I think one of the beauties of the agents themselves, right? Because all of these models are trained to be, super nice, super like helpful. And I've said this to multiple people that, if you talk to a human and you start, becoming like, let's say someone's really frustrated, for the right or wrong reasons, or they don't have the patience to deal with someone, they start hurling insults or being abusive and so on. A human can be thrown off no matter how much you meditate in your life or have been trained for it. You do in that moment feel really pushed. Whereas an agent will say, "Oh, I'm really sorry. Sounds like you're upset." Like even that example that I shared for the vet clinic, you're like, "Oh, I'm so sorry to hear your dog is not feeling too well," right? So that's that. But to give a technical answer to this, you can pull in like profanity filters, for example. You can also train the agent to say, based on certain things, you want to either end the call to save your money mostly, rather than worry about the patience of it. You can do that, and you can. That's where the conversational flow comes in, right? You can decide what your flow should be and then act accordingly. So there's both those things.
Just to add to that, maybe Ram's question would be relevant at a point in time where the user is unable to tell that they're talking to voice agent, and the assumption is going to be that this is a human who's calling me. I believe that in the voice agent application, the user is fairly aware that this is an agent that I'm talking to. Is that a fair understanding? Or you think the user could be tricked into believing that this is a human being that I'm talking to?
So not tricked, I would say, but I think we've kind of A/B tested this also, and we found that it kind of didn't make much of a difference whether you say it's just like when you're talking. It depends on how you want to do this, right? Because we have customers who, want to just directly say like, hey, this is, Christy from so and so clinic or whatever, because their end goal is not to trick anyone. Their end
Yes.
goal is just to be, an agent that can do the job. And so in this example, like, yeah, I mean, typically you wouldn't like have a customer say, just put down the phone. Typically the filters would obviously be such that they can detect the profanity. But once they do that, you can choose how the responsiveness should be. You can just say like be empathetic or be polite or understanding, because oftentimes that is what your job is, right? Even as a human, your job is to basically respond to an uncomfortable situation, whether it's for collections or whether your Zepto delivery did not happen.
Sorry.
That's the job at hand. And then agents are really good at it. Like they're really good at kind of finding a way. Very good at you can even train them for like negotiation, which is amazing.
Yeah.
Like, we've done that, and it's fantastic. Like they'll literally convince you to pay up.
There's another interesting question from Jayashree, and she says it's the last one. People with stammering communication, so stutter, stammer, is this area tested or handled?
Um, that's by the way, that's a very interesting question. I don't think that area has been explored yet, at least not to our knowledge. Um, I think that there are techniques to incorporate these kind of edge cases. For example, the speech to text, which has these, these flags that you can build in, where you want to pinpoint where the user has ended the conversation, right? So in cases like these, where you want to also expand to such edge cases of uh, you know, uh, the customer who might be stammering or you might be taking longer pauses. So you want to typically extend those duration or those windows of those flags so that you can be assured that it's just a pause and not the end of the conversation, right? So by building those kind of uh, you know windows of end of turn detection or elongated windows of end of turn detection, I think those systems can be built, but honestly speaking we haven't touched upon this part, and this would be a very interesting area to explore.
Okay, okay, that's
The, so
interesting.
just one quick thing to add is like related to this is also like things like your filler words, right? So
Yeah.
as humans, we'll say like and we don't want that to be seen as in as a like, hey, now I want to speak. It's more like, hey, I'm acknowledging what the agent is saying. So those things can be sort of plugged in, where you can say that if there's some filler words, then don't interrupt, I mean, or like don't stop speaking, for example, right? Like as an agent. So maybe along the same lines, one could solve for in the similar way, basically.
That's I think that it'll be interesting. I mean, I'll have to go deep dive tonight to understand who's written what on this. Okay. Two questions from Raj and Anita on cost. I think how much does it cost? Do you host the models? And then Anita wants to know what are the elements of variable and fixed cost for such agentic AI? What is the average productivity improvement you've seen?
Okay, so I think there, from a cost perspective, it depends on the markets that we cater to. So, for example, in a US, obviously, or in the UK market, the price points are completely different from an Indian price point. But obviously, as we know, Indian market is price sensitive, so you'll have to find those optimizations which can enable you to serve the Indian customers, right? So, without getting into the details of the exact cost, I would say that there are three cost components to this. The first cost component is, the one-time setup cost, which is obviously you want to set up this whole framework for your system. You want to custom train your agent on the specific data and those kind of things, right? So you want to have a fixed component for that. You also have a per minute variable cost, which is the cost associated with the tokens that gets consumed by the LLMs, or the conversations that happen, the speech to text and the text to speech components that you use. And the third component is, there's a nominal cost of a monthly payment that you would be making for buying or purchasing dedicated numbers through which you want to uh, send out these calls. So you might have to purchase those numbers as well. So that's the third uh, cost component, right? Of course, we can have a separate one-on-one discussions on that if you want to understand more about our costs.
I think the last question on chat before, I mean, if Gayatri permits me some time to ask my questions for another 5 minutes. Okay, last question. I think this is Anita. How do you see the level of engagement on a qualitative basis of an agentic AI versus a service support human agent?
I think that's also a very good question. So right at the outset, we don't have a standard benchmark yet for measuring the automation accuracy, right? Which is the percentage of calls where the AI agent completes a task um, versus how a human would have completed the task, right? So there are certain benchmarks around that which is not universally accepted. So, for example, for real world production systems that are fully automated, the benchmark is somewhere around 50 to 70%. And for narrow domains or scripted kind of scenarios like IVR flows or lead qualifications, that benchmark goes up to 85%. But again, there's no universal benchmark, so to say, or a metric that can help us understand. All these are areas of exploration. I think these are initial days for voice AI agents, and lots of evolutions and explorations are happening as we speak. So over time, we'll definitely have standard benchmarks around these setup as well.
I want to sort of ask a follow-up question on this, which is benchmarking vis-a-vis your chatbots. So you played us those demos where someone's booking a vet clinic appointment for a dog. So if the same thing I was doing through a chatbot on my WhatsApp, so is there a benchmarking on that in terms of either saving of time, cost, convenience, productivity? I mean, whatever metrics is being followed?
Yeah, again, that's also a very good question. So uh, the short answer to that is also there's no standard benchmark yet. Uh, but there are systems which allows us to measure the accuracies, right? So for example, when you have a chatbot and your customers ask you to either book an appointment or reschedule an appointment, you're dealing with text, right? And there's a low chance of that text going wrong, right? Because these are standard text which any system, any machine can nowadays understand with thanks to the LLM. But when it comes to voice bots, there are these error rates, which Sudhama mentioned a few while back, which is the word error rate, which is the transcription loss um, between what the customer has spoken and what gets transcribed and fed to the LLM. I think that's one of the error rates that that creeps into the voice bot as compared to a chat bot, and that probably leads to some 5 to 8% error rate in most of these standard scenarios.
Okay, okay. I think looking at the time, last two questions from my side. One is on the accuracy part. I mean, maybe if you can talk to us about the accuracy benchmarking. I mean, eventually it's an LLM being used for speech to text or a speech to speech, as you said, and in processing, there is something which is lost. So what is the benchmarking that the industry has for measuring as to what is the loss, what is the accuracy, or, are we just doing a ballpark sort of, okay, we're moving from something to something else, which is slightly better. So if you could talk to us about that.
Sure. So as I mentioned, there are three components in our voice AI voice agent, right? The STT, the LLM, and the TTS systems. And each component has their own accuracy benchmarks. I think Sudhama touched upon some of these metrics in the slides that he presented. So, for example, when you talk about the speech to text part, which is your speech getting transcribed and fed to the LLM. Some of the standard metrics that we use there is the word error rate, which for clean audio, especially in English scenarios, it's close to around 2 to 5%. But for Indian English, or for example, some of the noisy background audios, that error rate goes as high as around 8 to 15%. Uh, Now, the second component is the LLM, which measures what's the difference between the intent of classification, right? The what you wanted it to classify and versus what it actually ends up responding. So one standard metric to measure that is an F1 score, which in zero shot scenarios where you don't train the agent on any examples, that percentage or that benchmark is close to 75 to 85%. In few short scenarios where you give a few examples to the LLM and you train it on those few examples and then you put that to a live scenario, I think that accuracy benchmark goes to 90 to 95%. So that's a significant improvement as compared to a zero shot scenario. And then, last but not least, on the eval side, also there are certain benchmarks and metrics that are used, like Blue score or Rogue score. So people who are interested in that, we can share certain literatures around that. So
Sorry.
these are some of the metrics that are typically used.
Okay. Thank you for that. Penultimate question and then the last question. Okay, so the penultimate question being, I mean, there's too much talk about India sort of trying to build a foundation LLM model, I think, government's supporting Sarvam to do it. My question is in the context of voice agents and given the diversity of Indian languages, dialects, and I think there is something else also, which is, a subset of a dialect, all of that. I mean, if, we actually were to have a very good Indian foundational model, imagine which has a repository of good quality voice database of, everything that happens in India. I mean, is that something which would help improve? I mean, today you're using, the LLM models, which, is either Claude, OpenAI, Gemini, Llama, whatever it is. But if one were to use a foundational model where the quality of voice data for Indian market is very high, I mean, does that logically then change the quality of service which will be delivered through these voice agents?
So, I mean, so the short answer is obviously yes. But the problem is it's very hard. So, it's very hard. It's not just about building another large language model, right? Even for the companies that are doing this at scale, it's very hard to gather enough high quality, sort of recordings of conversations which also span across a whole different sets of contexts, right? So even the ones who are kind of looking to build language models specifically, let's say for voice, whether it is on the speech to text side or the text to speech side, they would be looking at using synthetic data, which is data generated in an artificial manner to be able to fill the gap of that volume. So once you can fill that gap, let's say with synthetic data, then you can make these models better. But that's an expensive and sort of tricky process because you're using small amounts of data to train, let's say large amounts. So just to give you some context, some of the models even for voice, right, and even in Indian languages are trained on, let's say 1400 hours or 5000 hours or 10,000 hours max of actual human conversation for specific languages. So imagine that's really not a lot in terms of, like, if you say like, okay, 1.4 billion people, how many conversations must exist? But it's very hard to get the high quality data. So essentially the path that people are looking at is through synthetic data in that sense.
Okay. Last question. I mean, what is your wish list for voice agents, to take over like the world of humans who have to talk and make calls? 2 wishes only.
All right. So actually, the wish list is quite long. But since you asked for two wishes, I would say the first wish and probably the broader, most stronger wish is these voice agents should not just be seen as tools, but should also act as extended teams of enterprises. Um, and I think that is already happening, um, given the pace at which the evolution, the technological, changes are happening. Um, there's a rapid evolution and adoption of these AI, voice AI agents in enterprises and startups alike. And the second one is it should free up human bandwidth for repetitive from repetitive calls, right? We don't want humans to spend their time on just uh, calling one customer after the other, reading out the same script and not doing any productive or meaningful conversation with the customers, right? So there are a lot of areas where humans can apply their intelligence and their creativity in better ways, and that's where these AI agents would allow us uh, to get more human bandwidth for these creative actions, and we hope that in soon these AI agents would work very reliably in a noisy environment, let's say in a multilingual setup, works 24 cross 7 and sees a rapid evolution and adoption across the board. So those are two wishes from my side.
That's interesting. I mean, before I let Sudama maybe make half a wish, on this and give him time for that, I think, I mean, so from what you're saying, I mean, the bottom of the food chain is definitely going away very quickly, right? I mean, people today who are, for whom the livelihood today is a call center, and perhaps that's the only skill that they have acquired, either in college or through a vocational training institute, that is going away, which means that the only possibly alternative for them, and we can't imagine that they'll be upskilled to a point that they can, move higher up in the food chain, is only physical labor. I mean, this is what I see. I mean, we're not seeing robots advancing as yet to, doing physical labor as yet, but this is a thought that comes to my mind, that if you're going to take away, and I'm not saying you, but I just mean, like, all of these agents. But if the bottom of the food chain is going to really not survive this, effectively, and they are not upskilled, for whatever it is, then, I mean, like we say that, we're going to free up time of humans to do better things. But I mean, if I think about it, what are those guys going to do? I mean, it does bother me, but I think that's for another day. Yeah.
For a separate debate,
Yeah.
and probably come up with the opportunities for such categories of people
Yeah.
and see
Yeah.
where they can be utilized. So Sudhama's half wish is pending before we
Yeah.
close.
Yeah. Half a wish.
Yeah, half fish is like kind of related because I feel like we strongly feel like, feel right. Obviously, with technology, try to improve things. But if you look at the whole, like, I think call center culture that evolved in India, it came, yes, like it brought in maybe jobs, it brought in those things, but it was like you're basically offsetting your life to
Yeah.
be available at 3 a.m., 4 a.m. in the morning just because you want to serve like some customer in a different country, right? And that's not a great life to have anyways. So, like that's not something you people aspire to do, but it's just something that they did because it felt like a low-hanging fruit which will pay their bills, right?
Mm.
So the other thing to think about is, and this is very common for AI in general and AI agents because we are pretty obsessive about that, is that 300 years ago, 97% of the world was doing agriculture. Now it's only 3% of the world, right? So people figure it out. So we will figure out the transition is not going to be easy, but we will figure out, what to do next. And if at all, maybe just sleep better. So
That's true. Yeah. Yeah. But thank you so much, both of you. I think this was a very interesting, very insightful session for all of us. I mean, we had until 5 minutes ago about 25 people. I think it's 9:25. People just dropped off. But yeah, I mean, we had a great time. Gayatri, anything that you want to add?
Yeah, this has been very good. You're just second in the series, and I think the topic was so intriguing, and you held the fort. Thanks to both of you, Rahul and Sudhama and Renu, the way you moderated this. I haven't seen people run away from the session. That's a mark of the interest you've created. Good job done there. Thank you so much. We should have more sessions, basically, in the future to probably go down with every possible topic that you have just touched upon today, because these are vast topics and a session of 1 hour will not do justice. And hence, we will continue to keep speaking. Thank you so much, and look forward to the future sessions. Thanks,
One
all of
last,
you.
sorry, just
Please
one last,
do write in your feedback. Yeah, sorry, Renu?
one last thing. I think some people had requested for the presentation. So Rahul and Sudhama, if you're okay with it, I don't know if maybe we can share the invite list with you guys, and you can just take it forward with that, I think.
Yeah,
Yeah,
I will.
absolutely. Yeah.
Mention the recording will be available, and
Oh, it will be available. Okay.
yeah,
Okay.
so I think it's not fair to take their stuff, so don't have to send it to
Ah,
anyone.
up to
Let
them.
them
Yeah.
look at the recording if they want to brush up. Yeah. All
Thank
right.
you.
You
Thank
have
you.
to answer questions
Thank you
also.
so much.
Thank you.
Thank you so much. Yeah.
Bye.
Thanks a lot. Bye.